Welcome back. Today we're going to be finding particular solutions to initial value problems. So far we've been taking integrals of indefinite integrals where we had to put plus c at the end of every problem because we didn't know what the constant was at the end. So now we have an x and a y, and we're going to be solving for c once we take the integral so that we have a definite solution. So if we look at example 1, it says find the particular solution that satisfies the given condition. So this is the condition right here. And we're going to take the integral just like we've been doing, and we're going to then plug in the x and the y so that we have an initial condition to solve for c. So let's start by taking the integral of 100 over t squared. The first thing I'm going to do is move the 100 on the outside. And I'm also going to move t squared up to the top. Then I'm going to apply my power rule where I add 1 to the exponent and then divide by my new exponent. So now I have negative 100 t to the negative 1 plus c. But I can rewrite that as negative 100 over t, because I want to move that negative exponent to the bottom, plus c. So that's r of t. That's my new integral, my indefinite integral. But I'm given an x and a y, so I can plug those in and solve for c. So 400 equals negative 100 over 1 plus c, which is 400 equals negative 100 plus c. And I'm going to solve for c. So c equals 500. So my definite integral is r of t equals negative 100 over t plus 500. And that's my final answer. So now instead of having a c, I actually have a value for c. Let's do another one. It says find y of x when y of 1 equals 0. So it gives me an initial condition. And I'm going to take the integral first. 2x to the negative 2 plus 3x to the negative 1 minus 1 dx. I can split this up, bring out the constant, Now I'm going to write this as 1 over x, and you'll see why in a second. So the first one, I add 1 to the exponent, divide by my new exponent. The next one, the integral of 1 over x is natural log x. And the integral of 1 is just x. And then I put my plus c. So that's what y of x is. So now I've got this function. I'm just going to simplify it a little bit. Negative 2 over x plus 3 natural log x minus x plus c. I'm going to plug in 1 for x. 3 natural log 1 minus 1 plus c, and that equals 0. So I have negative 2 plus 3 times 0 minus 1 plus c equals 0. Combine like terms, that goes away, and I've got negative 3 plus c equals 0, so c equals 3. So my final answer is y of x equals negative 2 over x plus 3 natural log x minus x plus 3 instead of plus c. Okay, let's look at another one. Find the equation of a curve that passes through the point x, y, if the slope of the curve is given by dy dx equals 2x at any point x. So remember, slope is the derivative. So they give us the derivative, so we're going to work backwards to get the original function. So I'm going to take the integral of this. I can take out my constant. That's x to the 1. So I'm going to use my power rule. Add 1 to the exponent and divide by my new exponent. So that becomes x squared plus c. I'm going to solve for c. So I've got 2 squared plus c will equal 5. 4 plus c equals 5. So c equals 1. So my original function, y of x, equals x squared plus 1. So we can apply this strategy to problems that involve cost and revenue. So they give us the marginal cost, and if you remember when we did this earlier in the year, marginal cost was the derivative of producing x units of a commodity as given by, so there's our derivative. And the fixed cost, that means the cost when x equals 0, so that's actually going to be our c. Because when x is 0, that's what your cost is. Find the cost function and the cost of producing 20 units. So they tell us the derivative. So to get our regular function, we're going to take the integral. So I'm going to take the integral of 0.3x squared plus 2x. So 0.3 integral of x squared dx plus 2 integral of x dx. So this is 0.3, add 1 to the exponent, divide by my new exponent, plus 2x squared over 2 plus c. So 0.3 divided by 3 is going to be 0.1 x cubed plus x squared plus c. So right now our cost function looks like this. But we need to solve the initial condition. But remember, the fixed cost, that means the initial cost, is 2,000. So I can replace c with 0.1 x cubed plus x squared plus 2,000. Let me fix this c to look more like a c and not c prime. And so this right here is our cost function. And then they want to know what the cost of producing 20 items is. So 0.1 times 20 to the third plus 20 squared plus 2,000. Type all that into your calculator. And the cost of producing 20 items is 3,200. So to summarize, we were given the derivative. We took the integral to get the original function. We were also given our initial condition, the fixed cost, the initial cost, so that we knew what c was. And then we plugged in 20 into our new function. Pause here and try the next example and see how you do, and then unpause to see the answer. Here's the answer to the next example. It says there's no revenue with 0 production. So that means when x is 0, y is 0. So we're going to use that initial condition to solve for c. And they want to know the revenue at 1,000. So they give us the marginal revenue, r prime of x. So we're going to take the integral to get r of x. And so that's what I did on the left side. I found the integral. Then I plugged in 0, 0 to figure out c, which ended up being 0. So our revenue function was 400x minus 0.2x squared. Then I plugged in 1,000 for x to get the revenue at 1,000 production level. This last one is meant to be more of a challenge problem, so you can give that one a try on your own, and I'll write the answer. You can pause here and try it. So here's the answer to the challenge problem. You won't have one on a quiz or test like this. It's just meant to give those of you who think that this is really easy and you're enjoying it a little bit of a challenge. So make sure you drop by my office hours if you're having trouble, and have fun trying these on your Math Excel.